Hello everyone. So today we'll be talking about chain rule in our differentiation. Sometimes when we are given a certain example to solve, just like this one, we all know that we can solve this one with our normal general formula. But what if this power is 10? Assuming this power is 10, we open this bracket, that is grouping this bracket into 10 places before we could solve it. However, with our chain rule, we can simply simplify it. Well, first of all, let's take this example 1 before we proceed to more complicated examples. In our general formula, our general formula is dy dx is equals to ax to the power of n, where we minus, which is equals to this power multiplied by the coefficient. The power also we minus it 1. We can use this formula to solve this particular example because the power is still small. It's not that magnitude. For example, if the power is 10, it will be very, very, very complicated for us to solve. That's why we will employ this chain rule in this example. But first of all, let's solve this particular example with our normal general formula. Okay, so our y is equals to x plus 1 to the power of 2. So let's simplify this before we employ our formula. Okay, if we open this bracket, it will be equal, y will be equal to x raised to power 2 plus 2x, right, plus 1. If we open this bracket, then we employ our formula, general formula. So our dy dx will be equal to 2 multiply the coefficient, that is 2 multiplied by 1 x, the power we minus it 1, plus the power here is 1 multiply the coefficient, which is 2 x, 1 we minus it 1. And we already know that a constant in a constant is always 0, or we place c plus c. So dy dx will be equal to 2 multiplied by 1 is 2x, 2 minus 1 is 1. So we can leave it this way because the 1 is invisible, plus 1 multiplied by 2 is 2. 1 minus 1 minus 1 is 0, and x raised to the power 0 is 1. So this 2 multiplied by 1 is still 1, plus c. So this is the answer. The dy dx is 2x plus 2 plus c. Or you can even leave this c, leave it this way. Okay, so if we are to use our chain rule to solve this particular question, chain rule, this is equals to the dy dx is equals to dy dz, or any alphabet that you will employ or that you will assign to the numbers or the core content in the bracket. But for me, I'm using z to assign the core content of the bracket. I'm going to explain further. Times or multiply by dz dx. Okay, remember that our equation is y equals x plus 1 to the power of 2. So here the core content of the bracket is x plus 1. And I told you that I'm going to use the letter z to represent this x plus 1. So our letter z will be equal to x plus 1. Okay, So if I are using z to substitute x plus y plus 1, that means our question will be equals to x equals z to the power of 2, right? Because z is already x plus 1. So our question now, instead of writing x plus 1 to the power of 2, we write z to the power of 2. Let them is 1 1, them this 1 2. So the constituents of our formula is dy dz. So we will look for dy dz and also for dz dx. So from here, from 1, we can get our dz dx, because we are going to differentiate this one in respect to x. So our dz dx will be equal to differentiating this one respect to x will be equals to 1, right? Because we have only alphabet here, which is 1, and our 1 is constant, which is 0 already. So our dz dx is 1, and we are looking for our dy dz now. So from this 2, we can get our excuse me, dy dz. So our dy dz will be equal to, from here, differentiating this y in respect to z, we will have 2 multiply 1 z 2 minus 1, right? So our dy dz will be equal to 2 multiplied by 1 is 2z. 2 minus 1 is 1. So instead of writing 1, we know that 1 is already invisible there. Okay, so our dy dx is equal to dy dz, which is what? 1 times dz dx. Wait, okay, our dy dz is 2z. From our formula, we have dy dz, which is this one, 2z multiplied by dz dx. Dz dx is 1 multiplied by 1. So our dy dx is equals to 2z. So we have gotten that our dy dx is equals to 2z. So, but remember, our z is equal to x plus 1. So dy dx will be equals to 2 multiply x plus 1. This is equals to 2 multiplied by x is 2x. 2 multiply 1 is 1. So you can see the same answer. If we use our chain rule, we're going to get the same answer as the normal formula. Or however, the reason for employing chain rule here is if you have a higher number as a power. That's where this chain rule is very, very effective. Thank you, and see you in our next class.